Now let's look at what happens when we sketch trig functions. There's one or two other things we need to check when we're doing trig functions. And the first thing you need to check is the period. So if I have the function f of x is cosine of x divided by 1 plus sine of x, I see this whole function has a period of 2 pi. So if I can pick just the right interval that is has a width of 2 pi, then everything else is just going to repeat. Now there's another trick I'd like to show you. Let me change f of x about a little bit. Let me make a small adjustment. It's just a trick, and there are other ways to do this, but I don't want a sum in the denominator because I'm going to be looking for vertical asymptotes. So I'm going to multiply by 1 minus sine of x and 1 minus sine of x. All right, and when I do this, and then when I simplify, I'm going to get 1 minus sine of x in the numerator and cosine of x in the denominator, because this is going to be cosine squared, and one of those cosines will cancel. This makes it very easy for me to see my vertical asymptotes are going to occur when cosine of x equals 0. So I'm going to have vertical asymptotes. Let me look for a good range that centers around 0 at x equal to minus pi over 2 and x equal to 3 pi over 2. So basically I just gave myself, I'm going to sketch these in, I just gave myself the range I want to deal with. I want to deal with axis from minus pi over 2 to 3 pi over 2, and then everything else will simply repeat that. So now let's go back to the original derivative, and let's do the original function. Let's do the first derivative. F prime of x is equal to minus 1 over 1 plus sine of x. Now it's very obvious for a couple of things. F prime of x is never 0. All right, now where does f prime of x, where is it undefined? And it's undefined, oh my goodness, at x equal minus pi over 2 and 3 pi over 2, okay? Since we've restricted our domain to minus pi over 2 to 3 pi over 2, that tells me that I'm not going to have any relative maxes or mins. Okay. Now let's move on to the second derivative. The second derivative of x is cosine of x divided by 1 plus sine x squared. Now, what does this tell me? What are my possible inflection points? Okay, my only possible inflection point in the domain that I have is x is pi over 2. And of course, this will always be positive down here, or equal to 0 at minus pi over 2. But again, we have the whole undefined thing going on there, so we've restricted our domain. So the test intervals we're going to look at, let's set ourselves up. If these are our values, all right, what is f of x, f prime of x, f double prime of x, and then the characteristics. This is mostly what you'll be doing on your graphs on your own. So let's start at x equal minus pi over 2. I know f of x, f prime, and f double prime are undefined. So I also know this is a vertical asymptote. Next, let's look at negative pi over 2 is less than x is less than pi over 2. Now, f prime is, let me go to my f prime, in this area right here between minus pi over 2 and pi over 2, f prime is going to be negative and f double prime, so that's always going to be positive, so I only have to really look at the numerator. So that's going to be positive. So I know it is decreasing and concave up. So from negative pi over 2 to pi over 2, it's decreasing and concave up. Now I really need to see what it is at pi over 2. X equals pi over 2. Then I know f of x is 0. F prime, when I plug in, is minus 1/2. And f double prime is 0. And this tells me not much just yet, except I do have this point right here. I can't say it's a point of inflection yet because I have to see what happens to the second derivative on the other side of it. So I do know from minus pi over 2 to pi over 2, however, I do know it's decreasing like this. So now let's go on to pi over 2 to 3 pi over 2. And let's see what that does. Let's see, the first derivative in that region is going to be negative, and the second derivative in this region is also negative. So the second derivative goes from positive to negative. All right, so that means this is an inflection point. Yay! But please note you couldn't figure that out until you had done the other region. Now in this region, this is concave down and decreasing. All right, and let's look at our other endpoint of our domain that we're looking at, 3 pi over 2. F of x is not defined, f prime is not. Okay, this is also a vertical asymptote. All right, so let me finish my graph. I got between minus pi over 2 and pi over 2. Between pi over 2 and 3 pi over 2, it's concave down and decreasing. So it's concave down and decreasing. So we have that inflection point there, and it shoots off. So now I know that this graph keeps doing that. Oops, that's not very close. My pen seems to be off. So it just keeps repeating.